Let's talk about a few of the most important examples of probability distributions. Binomial random variables are what you get when you try something a bunch of times and count how many times you succeed. Binomial distributions have two parameters, n, which is the number of trials, and p, which is the probability that each trial succeeds. The probability mass function of a binomial random variable is given by the following formula. For example, if you have a fair coin and you flip it 20 times, the probability of getting exactly 9 heads is 20 choose 9 times 1/2 to the 9 times 1 minus 1/2 to the 11, and you can sort of group these terms together and do a little algebra and maybe a little bit of a computer and get this. Geometric random variables describe what happens if you keep trying until you succeed. They have one parameter p, a number between 0 and 1, which describes the probability that any individual trial is a success. And the geometric random variable is defined as the number of failures before the first success. The probability mass function of a geometric random variable with parameter p is given by this formula. So for example, if the probability that I succeed on each trial is a third, then the probability of having exactly 5 failures before my first success is this. Poisson random variables are like binomial random variables when the number of trials goes to infinity and the success probability of each trial goes to 0. They have one parameter, lambda, which is a positive real number, and their probability mass function is this formula, which can be seen as the limit of binomial probabilities. Moving on to continuous random variables, the normal distribution, or Gaussian distribution, is a continuous distribution arising, according to the central limit theorem, as a limit of binomial distribution. It has two real value parameters, mu and sigma, and its density is this.